For this next question, what we're going to do is we need to firstly show that if this is my given function, that these are my first and second derivatives. So I'm just going to jump in and have a quick look at those. So my first derivative, 3x squared minus 3, and I can see then I can take out 3 as a common factor, and then I can see that that is the difference of two squares, which is awesome. That's my first derivative. My second derivative, I'm going to go straight from this part, and I'm going to use the power rule, so I just get 6x. So that's that part. Okay. Now I need to solve for where the first derivative is 0 and find stationary points. So here's my first derivative, 3x minus 1, x plus 1. Set that equal to 0 and solve. This happens when either x minus 1 is 0 or x plus 1 is 0. So I can see stationary points at plus or minus 1. Let's find the four coordinates. At plus 1 or minus 1. We want the y coordinate, so we need to look at this function here, x cubed minus 3x. So 1 cubed is 1, minus 3 times 1, so it's 1 minus 3 is minus 2. And then we work out the next one, which is minus 1 cubed, so that's minus 1. Minus 3 times minus 1 is plus 3, so we've got minus 1 plus 3, gives me that. So there's my two stationary points. And this is to establish, using the second derivative, the nature of these. So I see that the second derivative is 6x. So basically I want to look at f double dash of 1 is 6. So this means this concave up here, we just got this shape, therefore it's a minimum turning point. The second derivative evaluated at minus 1 is minus 6. That's concave down. Looks like that. So therefore that's a maximum turning point. Then it says to find points of inflection. So to do that we need to use the second derivative. We need to set that equal to 0. So I get 6x equals 0. That only happens when x is 0. Therefore x equals 0 is a point of inflection. I need to test it. And then I can revert the word possible. So let's just have a look here. At x equals 0, I need to test something that's a little bit to the left of it and a bit to the right. Point of inflection is where it changes concavity from concave up to down or down to up. I know it's 0 here. So I'm looking at y dash double dash equals 6x. At x equals 1, this is 6, so that's positive here. It's negative here. So it changes concavity, so it is actually a point of inflection. I can revert the word possible. Now I need to sketch and put all that together. What I've already found is that at the points 1, minus 2 and minus 1, 2, turning points. Remembering that at the 1 it was a minimum, so here it's a minimum, here it's a maximum. I know that the overall function is a positive cubic, so it's got to have extreme behaviour that does that. Also know that it's got a point of inflection here at 0, 0. Which means that's where it's changing from being concave down on this side to being concave up on this side. So that just helps we get our curves a little bit more accurate. What we haven't found yet are these intercepts. As you see here, I've already factorised our original function, took out a factor of x, do the difference of two squares. You can see this happens at the square root of 3. It's minus the square root of 3 here. This was the point 1, 2, 1, minus 2. There we go.